Morning to everyone. Today let us discuss about this data monkeying. It's a very important topic in data science. So data mining, as of course we know that the other name they call like data wrangling. What do we mean this data monkeying is nothing but we can transform the raw data. Maybe the data you can see that nowadays you can get like the data are clumsy or inconsistent. Okay, so in order to make this inconsistent data into like in a structured data clean format, we need this data monkeying or data wrangling. So once if we get this in data in a clean format, then I could say that it can be used for the analytic purpose, and also you can use it for your ML model, and we can ensure that the data is accurate and reliable, and it can be useful for making any decisions. So if you see that the various steps involved in data monkeying is we have like the first step is nothing but the data discovery, second step is nothing but the data structuring, third step is nothing but the data cleaning, fourth is nothing but the data enrichment, and then fifth step is nothing but the data validation, and then finally we can store the data. So these are the various steps that can be involved in your data monkeying. So let us go to the step 1, 2, 3, 4, 5. So before that we should know what is the importance of this data monkeying. So of course it can be used, it prepares the data in more organized manner, more structured data, so that it can be useful for analytics, reporting and machine learning, as I said earlier. So it will increase the accuracy and reliability of insights by removing those kinds of errors, and then it supports interoperability. So that is a major advantage of this kind of this data monkeying, and integration across various systems, whereby we are going for normalizing data into a common format. So to start with, like the different steps that are involved in a data monkeying, let us take one small example. So I am taking these voltage readings for different time stampings from 3 different sensors for a particular transformer. Say for example the time, if you look at the table you can see that the time sensor A, sensor B and sensor C. Say for the first time 0.01 times per, the sensor reading as voltage reading as 233, whereas sensor B is reading as 235 and sensor C is reading as 250. So similarly we can take all the data for different time span. You can see that there are 3 numbers which I denoted in red color. Okay, so that is that data is not available. Maybe like 0.02 in sensor A, it's denoting like there is no 0. Similarly in 0.02 the sensor C reads like the error as a thing, and then 0.003 it's given as any value. Okay, so we have to structure the data. Our second step is nothing but we have to structure the data. So for that I am replacing all the values. They replacing all the error values and null values with NA. Okay, so you can see that the previous whatever the value I given in red color, now it can be changed to NA, which is denoted by green color. Okay, so now we can see that in the 0.02 the sensor A is like NA, and then for sensor C is like an NA. So next is nothing but we have to clean the data. The data cleaning, we have to input some missing values. So how this can be done is making like the average adjacent value points. So here we are applying that the statistics, like say for example like your sensor A at 0.0t, we have to replace this NA value with 233.6. We just add these two values. The previous value is 233 and then the next value is 240. So take the average of these two values divided by 2, we can get like 236.5. So that is for I am replacing that NA value with 233.6, which is denoted in red color. Similarly, I can take for the second sensor C. I will take the average value of previous value is 250 and the next succeeding value is 251. You can take it, you sum it and divide it by 2, you can get like 250.5. So that is denoted here. Similarly for sensor B, so here we have find out the values for sensor C in the table like 250.5. So next step we have to find the value for sensor B. So just you can see that you can take these two values 236 and 237 and then 235, the previous value. So now we are having three values, whereas the previous one we are having sensor A, B, sensor A and C we have like only the two values. Here we can have like three values, so we can take the three values, sum of those three values and divide it by 3, you can get that 236. Okay, so next step is nothing but we have to go for the data enrichment, the process. Like we can add that to another column called as data enrichment. Here I am adding three columns, delta A, delta B and delta C. So in order to check the voltage changes between the consecutive maps for each sensor to predict the spikes. Say for example for the sensor A, you take the second times purchase 0.02, the value is 236.5. You subtract this to the previous value, you can get like the delta A value. So that is 3.5. Subtract 236.5 minus 233, you will get like 3.5. Similarly, you can get 240 minus 236, you can enter in the 3.5. Similarly for the delta B and delta C, you can enter all these values. So here I can get like 231 minus 240, which is nothing but minus 1. Okay, in the delta A, B and C, you can see that in the first column you can see that there is no values. I can say that in the second one we are getting the values. Okay, so this like I can give for this data enrichment. Then next step is nothing but the data validation. So once if everything is done, then we can verify the voltages within the safe bound. Say for example, like the safe bound is the limit is minimum is 200 volt and maximum is 250 volt, and then we can confirm all the data calculated delta values are reasonable. Okay, so if the delta value is exceeding 10 volt, I can say that it is like a spike. Okay, you can consider it as a spike. So above these data sets can be paused for validation and then it can be given for. So whatever the data there is given, the sample is given like good quality data. So once everything is done, validation is done, then I can go for this. Last step is nothing but the data storage. So save the clean data. So once the structured and validate the data in a spreadsheet or maybe like database. So now the data sets can be used confidently for performing analysis or maybe like anomaly detections or maybe like predictive modeling. Okay. Okay, so good afternoon to everyone. Let's see about this conduction of quiz. So what is the purpose of data monkeying? So as we studied data monkeying, what is the purpose of this data monkeying? So we have various options A, B, C, D. So the correct answer is to transform your raw data into your clean format for analysis. Okay. So let's move on to the next question. So during data monkeying, how it can handle a sensor data gap represented by NA1? Again, we have like 4 options. So what is the correct answers? So based on the concepts, the answer option B is the correct answer, which is nothing but replace with an average of surrounding values. Okay, so let's move on to the next question. So what is the first step in a data monkeying process? So the first step is nothing but your data discovery. So the correct option is C, which is nothing but the data discovery. Okay, so now I am giving like contra question, like real-time question. The company combines customer data from online forms and in-store surveys. Some customer appear twice with slight name variations. So which sampling step is needed? So the options are given. So the correct option is data cleaning. Okay. So we will move to next questions. Again, you have sales data with dates at 1/15/2023 and January 15, 2023. In order to make them consistent for analysis, which step is required? Again, we have the four steps. So the final answer is data enrichment. Okay. So let's move on to the next question. So data analysis claims that once the data is transferred, if no longer needs validation, what is the most accurate critic of this claim? So we have like the four options. So the correct answer is the claim is incorrect. So validation ensures accuracy after transformation. So option number B is the correct one. Okay. So which code creates an numpy array from a Python list 1, 2, 3? So the correct option is number 1. That is option number A. Okay.